Welcome to the Judy Shea Cam. I'm so excited. We're going to finish the lab today. But before we do, we need to talk about some of the things that happen in the lab and do a problem in number 2. So please do the best you can and we'll discuss them in a moment. Number 1 has 2 parts. First of all, it asks what gas was evolved when the zinc was added. Well, when we have copper 2 sulfate plus zinc, we get zinc sulfate and copper. There's no gas there, but we did observe bubbles, and that's the answer to the second part. And the gas is hydrogen gas. Because when we added the zinc to the copper 2 sulfate, that beautiful blue solution, then the copper dropped out and we saw the red copper in the bottom, and the zinc sulfate is in solution. The copper dropped out of solution. It's a solid. It's on the bottom. Now we know that we saw bubbles, and therefore there had to be a gas that was evolved. That gas came from the excess sulfuric acid in the reaction before, when we added the sulfuric acid to the copper 2 hydroxide. And we discussed that when we did the warm-up number 2 on the other day, and I'm sure you can go back and find which one it was, but we discussed that if we had 0.8 grams of the copper 2 oxide, which is probably close to what we had, it would only require 1.7 milliliters, and we added 15 milliliters, so it was clearly in excess. And that leftover sulfuric acid then reacted also with the zinc, forming the same product of zinc sulfate and the hydrogen gas. And so that's where it came from, and that's what it was. Now, I'll be back in a moment to discuss number 2. Number 2, it is necessary for you to read the question very carefully. And what it states is that 1 gram of copper is allowed to react to make the copper 2 nitrate. And you'll notice that you're given the states of all of these things. And the copper 2 nitrate is aqueous. And this NO2 is the gas, that brown gas that we saw come off in the very first day. And then we also get the water. Well, the question is asking for what the percent of copper 2 nitrate that was obtained in this reaction, and it was given that a student or someone started with 1 gram and obtained 1.5 grams. And therefore, we want to determine theoretically from the 1 gram, theoretically how much we should be able to get. This is a stoichiometry mass problem. And therefore, we use the first equation that we were given in the lab. And then we change our 1 gram of copper to moles. And 1 mole of copper has a mass of 63.6 grams of copper. And then I must change to my copper 2 nitrate in a mole-mole ratio. And the coefficient here is 1, and the coefficient here is 1. However, I must show my conversion factor to show that I'm changing compounds. And then I change my moles to grams of the copper 2 nitrate. And 1 mole of copper 2 nitrate, let's do that together. Well, we have 1 copper, which is 63.6. We have 2 nitrogens, and each one is 14.0. And we have 6 oxygens, and each one is 16.0. And then, of course, you know I do them again. 63.6, 28.0, and 96.0. And when we add them up to get the total formula mass, we come up with 187.6 grams per mole. And this is my conversion factor. And moles goes on the bottom, and the AMU goes on the top. Now, when I do this math, I come out with 2.9496, and I want to use this number in my percent calculation because I want it to be more accurate. Well, the student had gotten 1.5 grams. Therefore, we take the amount that was obtained and we divide it by the amount that was theoretically possible times 100. And then we get 50.8543. And we always take percents to the tens place, and therefore my answer is 50.9% of the copper 2 nitrate was recovered. Now that is in the it's in the analysis. And I told you I'd help you with everything, and we know that when we did this reaction, not only did we get this brown gas off, but it was hot. Therefore, it was exothermic. And that's how we know the difference. Exothermic is hot, and endothermic is cold. And that's all it's asking for in that question in the analysis. Now I get to see you in the lab, and we're going to finish up. I'm so excited. I'll see you there. Here we are at the scale, and I'm going to go ahead and zero it out, and then we are going to measure the mass of an empty evaporating dish. And here's my evaporating dish, and I'm going to get the mass of it empty. It's critical that I get the empty mass. And it is 43.63 grams. 43.63 grams is the mass of my evaporating dish. And now I'm going to go to the lab station to do the final cleaning up of that copper, and I'll see you there. Here we are on day 3 of our percent copper lab. It's so exciting because today we'll find out how we did on this. Well, I have my solution of zinc and sulfate ions, and the copper is on the bottom. And we must just clean up this copper and dry it, and then we'll get our final mass. I'm going to pour the water off of my copper, and it's solid, so I'm not too concerned about losing too much of my copper. I'll try to stop any of the ions that are trying to come out. And because we are going to be washing it with distilled water anyway, I'm going to use my wash bottle because the copper sticks to the beaker and is difficult to get out. So as I wash it, in order to get it out into my weighed evaporating dish, I will use the water here to get my copper out. And then I will also get the copper off of my stirring rod, because remember, we're trying to have the maximum amount of copper returning that we can. Inspecting that stirring rod. Now, I need to get all of the copper off of the beaker, out of the beaker, and into my evaporating dish. And I'm not too concerned about the amount of water because I'm just going to decant it anyway. I want to make sure I got all of the copper, my solid copper, off of this evaporating dish, or excuse me, off of my beaker. Then I will allow it to settle, and I will decant off this water. Now there is a little bit of water in here, and I'm going to wash it with my methanol I don't want to pour too much off because it seems that the copper is trying to get out. Now I'm going to put a little, it calls for 5 milliliters, but I'm just going to give it a squirt, wash it around, and I will let it settle. And I'll be right back. Now I have poured some methanol onto my precipitate, and I'm going to decant that as well. And sometimes there's copper that comes out here. I'd have to be very cautious and try to pour off as much as possible. Now I'm going to add the acetone, and it calls for 5 milliliters, but I'm going to give it a good squirt. And my particles are very, very light, and I'm going to stir it around a bit. And there's my solution. And now I'm going to decant that acetone off. Acetone, as you know, is fingernail polish remover. And nicely, nicely poured off. Now, I want to get off as much as I can because we know it's very, very flammable. There we go. And now I'm going to put it on a steam bath to dry it out. We do not want the Bunsen burner flame to go directly on the evaporating dish. We want to be gentle. And therefore, we are going to use a steam bath. And I'm turning on the gas and lighting the Bunsen burner. Woo! Sometimes it's more challenging than others. And it is a little bit high there. So I'll turn it down a bit. And we will go ahead and heat it. Now the difficulty in this part is that we cannot see water molecules. And it may have the appearance of being dry, but yet it's not dry. And therefore, we're going to time this for 5 minutes so that it continues to dry. And if our mass comes out to be too high, which I can tell because I have the empty mass, and then I'll make my subtraction and see how close I'm getting. If it's way, way too heavy, I know there's probably still water in there and it needs to be heated longer. So I will go ahead and heat this and dry it up, and I'll see you in a moment. Well, I believe that the copper is dry now, and you were able to get a bird's eye view of that copper and see the color change and see its beautiful red color. And it is definitely uniform in appearance. So I will turn off the Bunsen burner, sadly enough, and I will cool this. And I'm using my hot hands here to remove the evaporating dish and set it on the lab station. Now oftentimes students want to go ahead and weigh it, but we cannot weigh anything on the balance or scale that is warm at all. It must be completely cooled for 2 major reasons. One is that hot air rises, and the scale will have a very difficult time reading the mass when the hot air is pushing the evaporating dish up. And secondly, it's just not good for the scale. So we don't do that. So I'm going to go ahead and cool this down, and I will see you at the scale, and we'll find out what the mass of the copper is. Here we are at the moment of truth. Well, I have cleaned up the copper, and we have gotten it back, and it's so beautiful, and it is uniform in its appearance. There are different size particles, but they're all copper particles. And it was cleaned up and dried, and now I'm going to determine the final mass of the evaporating dish with the copper. And I need to make sure that it's in the center of the pan. And the final mass of my copper is 44.12 grams. 44.12 grams is my final mass of the copper. Now you have all the numbers that you need, the original mass of the copper and the final mass of the copper in the evaporating dish. You could do all the calculations from there, and we'll discuss some of the more specifics about the lab on our next time together. And I can't wait to see you then. Thanks for being here, and we'll see you tomorrow. Bye.